Alright, today at SycoTech Labs we're going to enter the danger zone. You see we got 2 meters here. Okay. We have to test the high voltage going to the driver and the final stage. We're not really making power. So this test's just like a car. Car, you need, air, you need fuel, you need spark, and you need compression. Okay? So today we're going to pretend that we're checking out the spark. Yeah. Let's think of the tubes as pistons. Okay. And if they're low on power, it's just like low compression on the engine. You're just not going to get the horsepower out. I got to turn this thing on. We got to warm it up for a minute or two. Then we got to actually key it. Once I key it, I should have 980 volts-ish, more or less-ish. Anyway, definitely should have some high voltage up to the top of the tube, so let's get her done. Yes, I hate this. Not my favorite thing to do. Yeah. Alrighty. Well, as you can see, the meter's going crazy. Yeah. If I was down there actually at the capacitance bank and the diodes, it would show 980. But by the time we get up here to the top of the tubes, may have a little RF action going on. So yeah, overloaded the meters. But hey, that means we have the high voltage going to the tubes. That means the high voltage relay is working. So the whole bunch of circuitry there we're not going to need to test now. So we'll have to look elsewhere and find our missing RF power. I said we're actually putting out less power than we're putting in. It's the opposite of amplification, whatever that is. Yeah. Anyway, so tomorrow we're going to let this bleed out overnight. And then tomorrow we're going to come in. We're going to go through some other circuits, test them out, try to find our missing RF power. Catch me later. SycoTech Labs, over and out. Howdy. Last time on SycoTech Labs, you'll remember that we tested the high voltage at the driver and final stage, and we had that high voltage, so we're not going to check the high voltage relay, a whole bunch of other circuits. So next, we need to figure out where we're missing our RF power. Okay. I need to test to see if the driver section is putting RF into the final section. Now, let's get down to tricks of the trade. I don't show everybody everything, but you know what? I'm coming up on 63 years old, and I'm probably not going to live forever. I'm going to go ahead and show this little trick of the trade. So, how in the hell are we going to measure the input into the final stage? Okay, the input of your tubes, especially in a grounded grid scenario like this, so your input's going to be the cathode. Alright, so we're going to want to test and see if we've got RF power going into the cathodes of the final stage. How do we do that? That's one of those tricks of the trade. Okay, so we're going to take this dosimeter, goes to 1,000 watts. And you know the driver's not doing 1,000 watts. One coax connected to the input. Okay, at the end of that coax, ooh, alligator clips. Alright. So the dosimeter is on 300 watts. We're going to connect to the cathode. And we're going to find a good ground source and connect to that. Good safe ground source. I don't know. I think it's right there. It's probably good enough. Okay. So, next thing to do is plug this thing in and turn it on. We already have the radio cable in. And we have power going in and out, so the pass-through is working. Water-cooled dummy load is on, just in case this thing decides to put out power. Make sure there's nothing underneath there. Okay. Turning it on. So we're going to let it warm up. And then we're going to be looking for wattage on the that little dosimeter. If it goes up, we know that the driver stage is putting power into the input of the finals. At that point, then we're going to be looking at the output side of the finals to see if that's where we're losing it at. Yeah, it's probably good enough as far as warmed up. Hello, hello. Audio, audio. So I'm showing nothing. Hello, hello, hello. Hello, hello, hello. Okay. So that test is complete. Powering down the unit. The meter didn't go up at all. Okay. Now, hang on, there is another switch. This is actually a triple stage. I haven't really traced this out. There's no operation manual for it. There's literally like about 5 Phantom 500s, 5 different ones. So we try with that switch foot. And no different. Okay, so the driver stage is not putting out any power into the final stage. So we're going to go through and trace all that out after a while and see if we can figure out why we're not getting power. If there was any wattage going into the final stage, that meter would have went up. It's not a perfect measurement. I know we don't need to hook an antenna to the output side of it. No, we really need to. We're parasiting off the circuit. So absolutely no movement, which means we're absolutely getting nothing into the driver's stage or the final stage from the drivers, which all the driver tubes were flat in this thing. So we've been really cautious. I haven't put these two new old stock tubes in it yet. I'm running with a couple bad ones and a good one in there. So they're not totally flat. We definitely should be getting power. So I would say we're going to have to be looking at the whole thing from the plate of the tubes, trace it all out, check every aspect of it, and see what the heck. Figure out why we're missing our drive power into the finals. Solve that mystery, and this bad boy might put out power. So, catch me later. SycoTech Labs, signing off. Okay. So, there is schematics for Phantom triple stage. Okay? And operation manual and blah, 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 blah. Like I said, there's more than one Phantom 500. Actually, it looks like we might be looking at 6 of them now. 6 different Phantom 500s. Okay. So, why isn't this like the Phantom triple stage that I have the schematics to in manual? Well, guess what? It's multi-band, and this one is mono-band. And something that has been bugging me. This is the output right here, which goes through the Pi network from the finals and through this relay. You know, if that relay is keyed, then it sends it out the antenna load. It shouldn't have this on it right there. So it looks like what they're doing with this relay, when it's on high power, the driver stage is feeding into the final stage. That's what it's starting to look like. Okay. When you go to low power, it looks like it's bypassing the circuit to feed the final. Normally what they do is they just neuter the voltage down. So you're still running all the tubes, but you throttle it down to low power by reducing the voltage. This looks like they're shooting the output from the from the driver's stage, or outing it around here. So it put out hot power on high power. Alrighty. Let's run our input test again. So we're going to the cathode and chassis ground. Wish I had something better to clip on that ground. I don't really like that. But safety be damned, right? Alright. We're going to be watching for that meter to move. This meter is not hooked to an antenna. We're going to flip it up to the 300 watt scale. It's just hooked to the cathode of the tubes there over the finals. So we are going to leave it on high power. We're going to warm it up. Audio, audio. Audio. Hello, hello. Audio. Audio. All right. Now. Audio, audio. No input at all to the final stage. Audio, audio. Audio. Okay. Now that is weird because none of them are wired this way that I could ever recall. I've never seen one built and designed like this. So this would make a sixth variant of the DNA Phantom 500. So when you go to low on this, you're only running the driver tubes, and yeah, I don't like that at all. I wish it was wired like normal, but anyway, yeah, we're getting about 250 watts out of it right now. They actually said if you run it on high power, I think you're supposed to have that on. Hello. Okay, so a little of the mystery unraveled, and you can see that, yeah, my old trick of the trade does work. Everybody wants to know, how you measure between stages. That's how I do it. Yes, you could use an oscilloscope too, but I don't know. That's easier to read. The meter's going up. We're not putting that much into the driver's stage. Into the final stage. Just a few watts, enough to tickle it. So we got issues in the driver's stage. That's why all the tubes in the driver's stage were blown. We're going to have to go through and trace that out, get the driver's stage working right, and then low power will work right. We still got a voltage issue with some voltage bleeding through something. Given the high voltage, a little bit of voltage at the plate when the relay is unkeyed, so that's not desirable. Causes a tiny bit of hiss on the receive of the radio when you turn it on, and it starts to do that. So anyway, that's where we're at. Now we're leaving this thing alone. This day is over. Catch me later. Okay, we puttered around. It's one relay. We went ahead and actually pulled it apart and checked it out and serviced it. We're going to go ahead and warm this thing up again and flash key it a few times. See what all happens now. So, wish me luck. Waiting for it to warm up. Oh boy, doopy doopy doo. Transmit mode. Audio. 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 Not a lot. Audio. Audio. Hello, hello, hello. Audio, audio, audio. Well, not working super great, but kind of working. I think we're going to call that a day. We're definitely getting some power out now. So, yeah. It's kind of alive. It's slowly coming back to life. Got some issues, though. I do still got some issues that we're going to have to trace out. And, yeah, it looks like kind of an advanced problem. I got a little bit of voltage bleeding into the high voltage on the final stage when the thing is unkeyed. That I got to figure out. Probably a disc capacitor leaking. Well, plenty of disc capacitors, so that's one of the things we're going to have to go through and address. Anyway, that's it for this episode of SycoTech Labs. Catch me later.